you haven't done so yet, please pause the video and try to solve the question on your own before listening on. What we can do first to solve this question is to draw a picture. So we have point A that's located at coordinates negative 0.05, negative 0.2 meters. Point B is located at negative 0.05 and positive 0.2 meters. And then we've drawn an orange vector to represent the electric field that's pointing in the positive x direction, and a blue vector that represents the electric field pointing in the negative y direction. Now, in order to calculate the potential difference VB minus VA, we have to imagine that we're taking a test charge and moving it from point A upward to point B. More specifically, we're moving a positive test charge from point A straight up to point B. Now, as we move the charge, we know that the potential difference can be calculated using this formula. And what we want to notice is that the angle between the displacement and the electric field is going to equal 180 degrees. And to understand that, just think of a displacement vector pointing in this direction. We can call that ds. We know the electric field is pointing downward, and from that drawing we can see that the angle between that displacement vector ds and the electric field vector would be a full 180 degrees. Now, when we simplify the dot product to E times ds times the cosine of theta, we can see that because theta is 180 degrees, that the cosine of theta is going to equal -1. We can also bring that -1, because it's a constant, to the outside of the integral, and that's going to actually make it positive. Also, the question states that the electric field is uniform, so that means E is a constant, and it too can be removed to the outside of the integral. Now, the integral of ds is simply the distance from point A to point B, which means that this entire integral can be replaced with just d. Now, it's important to note with regard to the electric field pointing in the x direction that we actually don't have to concern ourselves with that. And the reason is as follows. As we move the charge from A to B, again the displacement points upward. The electric field in the x direction is pointing to the right. Now, if you look carefully, you can see that the angle between the electric field in the x direction and the displacement vector is 90 degrees. And we know that the cosine of 90 degrees is equal to 0. So that's going to eliminate this entire electric field from consideration. In other words, we only have to consider the electric field that's produced in the y direction. And so to calculate that potential difference, we simply take the electric field in the y direction, which was 45 newtons per coulomb, and then multiply it by the distance between point A and point B, which we can see from the diagram is 0.4 meters. And when we multiply this out, we get positive 18 volts. And this indeed will be the correct answer. Thanks for taking the time to watch the video. If you liked it, please click the thumbs up icon and subscribe to the channel so you could stay tuned for similar videos. Remember, you can send in your own question to this email address, and I'll do my best to post an answer to it on YouTube.